We're going to have a look now at how we resample our image to a geometrically corrected file. And so what I've got up here now is my two images. The one on the left is the one that already has coordinates attached to it, and the one on the right hand side doesn't currently have map information. And you can see the spread of the ground control points that I've already collected on both of those images. You'll see that it's not exactly perfect. There's some areas where I can't find any ground control points, and of course there's no areas in the water where I'm going to be able to find those. So I've done the best that I can. At the moment you can see within my ground control point listing I've got a total of 11 points, and if we bring out that table a little bit larger you can see the errors associated with each of those individual points. And bearing in mind that we want an overall error of less than 1 pixel, so there's a couple of points here which I could perhaps look to move or remove. So point 11, 9 and 1, they've all got an RMS of greater than 1, so I could perhaps revisit those. Now if we look in the ground control point selection window, you can see the overall RMSE of just under 0.8 there, which is good. As I said, we want to have that less than 1 pixel. So we can change our individual points, or we can say that we're going to be happy with that less than 1 pixel there. The other thing that we can do to reduce the RMS is to increase the polynomial degree of the transformation equation. So if I change that to a second order polynomial there, you'll see that the RMS error changes, so we're now down to less than 0.4, and the individual RMS errors for each of those points also decreases, and that's just because the model is able to be fitted a lot better to those individual points rather than being such a rigid model there. You can have a look into the help file to get a little bit more information on exactly what's occurring there. So we're going to stay with the second order polynomial at this stage. We could increase that further if we have the right number of points to do that. I'm just going to go up to options and then warp file, and what I want to do is to warp this non-geometrically corrected image. So that's the image that was on our right hand side there. So just select that one and click OK. And now we've got a few different options here that we can change. The only ones that we're going to play with are the resampling ones. So we've got the options of a nearest neighbour, bilinear interpolation or cubic convolution. So there are 3 options there. You can also change the degree here depending on the number of points that you've collected. So the idea is to have a look through actually creating those files. So put an output file name in there in the directory that you're working in, and run those equations and have a look at the output files. So I've already created those, so what I'm going to do is just to bring those up in a viewer here, and if we remove that file, we've got, so on the left hand side is the original image that has the coordinates attached to it, and what I'll do is I'll open a new image. This is the nearest neighbour image that I've created here. And so first of all you can see that the image is now oriented in the correct way, whereas the image that was uncorrected was just oriented straight up and down, whereas this one has been rotated slightly clockwise there. But what you can see is that the corners are no longer at right angles, so we've got some distortion happening along the southern border here, and perhaps a little bit along the eastern border as well. So that's not that great. What we want to do is to have a look at individual locations and see how far off we are of where the pixels actually should be located. So I've geographically linked those, and what I'll do is I'll go into a particular location. So we might drop into this location to start with, and have a look in our zoom window to see just how close the pixels are. So you can see they're pretty close. If I was to overlay one on top of the other, we would see some variation there though. As we move around the image, you can have a look at different areas and see just how far off our correction is, and you'll see in some areas it's probably better than others depending on exactly where we've got those, where we've put in the ground control points to start with. So that's one check that we can do. The next thing that we want to do is to have a look at the effects of the different resampling. So now on the left hand side I'm going to have that nearest neighbour file, and on the right hand side I'm going to put the file that was created using the cubic convolution resampling. Okay, so as you can see, the files in the scroll window look exactly the same. Okay, so that's because we're zoomed out to a fair way, and the exact same equation was used, but it's just in terms of looking at what pixel value is going to go into each individual pixel that's going to change. So this time we'll use the link displays option and link those two viewers. Go into an area, and you can immediately see sort of around these border areas of the mangroves just in the left hand viewer how different they are in terms of their smoothness, I guess, compared to the one in the right hand viewer. So again, the nearest neighbour in the left and the cubic convolution in the right hand side. Now because I've got those two viewers linked, and they've got a dynamic overlay now, and what I can do is we'll have a look in the zoom window as it becomes a little clearer. I'm just going to use my left mouse button on the zoom window and click, and you'll see that the images are dynamically overlaid, which means that I'm going to flicker from one image to the other. So at the moment you can see the cubic convolution image, and as I click it you'll see the nearest neighbour image there, and you can see that there's some variations in terms of the pixel values, but spatially the features should appear in the same location. So if we move around to different features, we'll see just how much of an effect that has there. You can see it in the image window as I do that dynamic overlay as well. And we'll bring up those zoom windows there, and you can see the effects of the individual pixels there. So have a look at a few different land cover types and different features and see the effects of using these different resampling methods, and try and understand when would be a good time to use the different resampling methods and the trade-offs between those.